Welcome to econometrics. We are going to be dealing with assignment 1 today. It's actually the first class anyway of this semester, so we'll kind of lay up a bit of some foundation on this module. And I think I do have a recording on the first 2 chapters, so I might not have to repeat that. So I think I'm going to send the recording after the session. I'm just going to have to look for it and then send it through in the group there. Right, but I think we will be breaking down this stuff as we tackle these questions. I'll see what can be explained briefly and then what cannot be explained briefly, of which I believe there's nothing that can be explained briefly. We will be tackling on that on those other videos, right? And in our next sessions. Then I intend again, by the way, as we keep going with this module, to be tackling examination questions so that we familiarize ourselves with them. So the whole strategy is section A of our examination is more of, there's quite a lot of theory on that. Most of it is theory, definitions and the like. So we'll be doing that. There are not many tests that we normally conduct on section A there. Then section B, that's the part that we are gonna cover much later. So that's when we'll be looking at where hypothesis testing comes in, and then maybe some of those other tests, right? We'll also be looking at some of those. Basically, our analysis of the regression model, and then looking at some of the problems that could arise, the specific problems that could arise in this regression model, and then how to solve, right? I think in the words that they use in this module, they say how to, the remedies, right? The remedies of these problems that we will be facing here, right? But in any case, let's jump to question number 1. All right, so which of the following statements is or are true? Regression analysis is a statistical technique that describes how, okay, so let me see if I can, I think I'm going to be drawing answers here. Let's put it in red, right? We're going to put that, our answers in red. Let's make it a little bit thick, right? So most of what we are doing in this module, in this part of the module, is going to be regression analysis, which basically talks about the relationship between 2 variables, right? Basically describes a relationship between 2 variables. It can be any variables, but because this is econometrics, we are dealing with mostly economic variables, right? So I think the video there is going to explain that econometrics is measurement, right? We're talking about economic measurement there. So this is what the module is basically about. And then part of what the module is going to be dealing with is therefore looking at this relationship between 2 or more economic variables, right? That's what we are going to be dealing with. But in any case, we are looking for the correct statement here. So let's rule them out one. So several explanatory and several dependent variables are related. So let's first explain what an explanatory variable is, as well as a dependent variable is. So the other word for explanatory variables is independent variables. I think from mathematics, you would normally know them as independent variables. And then these are the x variables, right? You find these ones on the x-axis. They are independent explanatory variables. And then the dependent variables, these ones are on the y-axis. But why do we call this the dependent and this one the independent or the explanatory? Merely because since we are looking at a relationship between 2 variables, right? We are trying to see, right, if we're going to plot this on the Cartesian plane, which is your XY graph, right? If we are going to plot that, we are looking at a relationship between those two variables, trying to see what happens to another variable when there's a change in another variable, right? I think that's familiar if we're going to talk about what happens to y when x is changing. So in economic terms, I normally use the example, something that we're normally used to if you're going to be looking at price, the price of a product versus the quantity demanded of that product. So in that instance, right, the independent variable, which is going to be the explanatory variable, right, in most cases is the price, right, is the price. So we'll be saying that the price explains the changes in what? The price explains the changes in quantity demanded. So the price is the explanatory variable. So it's the independent variable. So we are assuming that the price is not going to be affected by the quantity demanded, but it's the other way around. Okay, but we are going to hear more of that on the video anyway. So one is called explanatory variable because we are saying it's the one that explains movements in another variable, which is the dependent variable. So the dependent variable is called the dependent variable because its movement depend on another variable, right? At least that's the theory behind that, right? Whether that applies in reality or in any model, you need to test that and see. But this is basically what this is about. And of which, in any case, we do not deal with several. There is normally one dependent variable, right? And then many, they can be several, one or more explanatory variables. So which makes number A wrong, right? It cannot be many dependent variables because we are saying these must explain the movement in that. So we can say these must explain the movement in these. So it must be many to one or one to one. So there only has to be one dependent variable. So it's one on the y-axis there. And then B, one explanatory variable and several dependent variables. So this is still wrong for the same reason as that. This is still wrong for the same reason as that. So as you will see in regression analysis,
Hello.
I just got kicked out on that one. Okay. All right. So I was saying A and B are both wrong for the same reason. So you have to have one dependent variable. Then for explanatory variables, they can be one or many. So which leaves us with option C, one dependent variable and several explanatory variables are related, right? So which gives us option C, which is that
Dando, someone is asking if you can let them in. Dando, I'm not sure if I cannot hear you. Can you hear me?
yes, I can hear you. Sorry about that. I think I was muted there.
Oh, okay. And there's someone who's saying
If two variables y and x.
Okay, sorry to interrupt you. There's someone in the group who's saying, can you please let them in?
All right, just did. Thanks very much. I just hey, network is giving me troubles here, but they are in. All right, so if two variables y and x have a positive linear relationship, so if it's a positive linear relationship, it's usually gonna be, if it's x then okay, I don't want to draw now. If it's x and if it's if it's y and if it's x like that, a positive linear relationship is usually gonna be, it's actually gonna be like that. Okay, but the question is, if there's a positive linear relationship, we can conclude that x causes a change in y causes a change in x, then there might not be a causal relationship between x and y. Is regression analysis basically shows the relationship between two variables. So in other words, the graphical representation is just going to show us whether it's a positive relationship or a negative relationship, or maybe how well the data fits into our regression model, etc. But what it does not do now is to show us, right, or to try making conclusions as to a cause of what causes this economic measurement. Like we are simply measuring economic variables, see how the changes were in a period of time. For example, for the changes, we need to research on that. We really cannot draw conclusion on that. So merely based on a positive relationship, we just cannot conclude that. Many things have positive, they cause each other. They can really be unrelated, but still have that kind of relationship. Right. In regression analysis, if the dependent variable is measured in kilograms, exponential must also be in kilograms. Take any unit of measurement cannot be in kilograms. So economic measurements or any kind of measurements, you can basically test anything with your regression analysis. You can basically, it's not a must that kilometers given where you range, it could be units, it could be liters. So it's not a must. It can be in kgs, but again, it's not a must for in kgs. So the conclusion is be there, right? It cannot. Okay, let me delete misleading signs there. Option 2. Okay, so if it's kilograms, it can be kilograms to kilograms, because you might want to assess maybe it's manufacturing process. They say my hundreds, I think it's the network for it's a manufacturing process, and in a manufacturing process, you might have an input kgs, right, and then so this is where to how to keep in a certain input, which is also a so not they must. So some can take any use of measurement. Let's jump from that. So now we are jumping to where we are given growth. So in economic vision is interested in economic growth. So we are given, and so I'm gonna are you able to see my screen?
Yes.
Yes. Say on my side, I can't hear anything.
We can see, but then I think your network is bad.
Right, can you just confirm if you guys can see my screen? Then let me see.
Yes, we can see it.
You can see the screen. Okay, perfect. Okay, so we are gonna let's deal with these questions based on. So we'll be moving from the Excel spreadsheet from the spreadsheet right through to this PDF here. Right, which of the following statements is correct? The degrees of freedom is 29. The sample average of what's the, we said it's exports, right? The sample average of exports is 2.42. Sample average of growth is 26.09. So we are going to test all those just now. All right, let's right, so let's start off with the degrees of freedom. So how do we get the degrees of freedom? Right, we look at observations, right? The number of observations. So the number of observations, we can check that down there, it's 29. So it's just simply counting there, right? So if it's 29, the degrees of freedom for when we're with regression axis, we always want to subtract 1 and then minus the number is the explanatory variable. So in this sense, we want 1. In other words, it's one coefficient that we are going to be dealing with. So our correct answer needs to be 29 minus 1, or basically minus 2. So this is what happens. So this is under the circumstances that we are dealing with a simple regression model. So I think this is also there in the video. So you basically look at, it's gonna be n, I think it's written as n minus 8 minus 1, right? Where k, you are basically looking at the number of beta coefficients, like beta coefficients in terms of the explanatory variable. So in this instance, we are only dealing with 1, right? And then this other one here is for other beta coefficient is a constant. So it's written as minus 1 because it's a constant, it's not changed. This is always going to be 1, right? K can change because in some instances there can be more than one of those other explanatory variables. So which makes the first option wrong, which I said, right? And let's look at now assess growth. So what average there of growth. So if we are using Excel, if you struggle with this assignment already, it could be because maybe manual calculation everything. So as you can see, I've just highlighted from 2, right? From row number 2 through until row 30. Then if I look down there, it gives the average 2.4. The average of what? Of 9. So we come and check the average is 2.4. right? So the 2.4 is not for 2.4 was not written, it was actually written under export. So let's see now what's for export. They give 26.0999. So let's just recheck that now. See 26 point. So it's still, so none of these are correct. So they just by space this. So just make sure not to be confused with that. So which means none of these options are correct. Right. None of the options are correct there. So this is actually very easy. Right. And then summation of x squared, right? Summation of x squared. Let's do that. And then we also need summation of xy, and then the residual, summation of this residual. So this is not, it will not be zero anyway. So we can simply rule that out. So if you're like me and you hate wasting time, I know for a fact that ordinary least squares must give us ordinary least squares must give us a summation of these residuals as zero, not the residual squares. The residual squares. So it makes wrong. So I can basically look there and see wherever there is B is wrong, right? I just automatically rule out those answers and then check now A. Right. Let's have a look at A. So we are simply going to run calculation here. So this is Y and this is X, right? So let's start off with, I think they want summation of X, right? Summation of X squared, right? So this is your X there, and then to the power of 2, it gives us a certain value there, right? Let's check that. I want to see what that gives us, right? So it has basically calculated all of that there. So summation of X, which is the total of that, you can simply find total at the bottom there. Ne? It's given there. Sum is 200, 2000. It's 20,084. But if you like to do it the longer route, then you can as well type your sum there, and then you might wanna put in all these amounts there. But it will basically give you the same amount there. Right. So that's the same amount that we had there. So it's 2084. I don't think it matches the amount that was given there, not at all, right? Summation of xy, let's have a look at summation of xy. They are given a negative 20, 27. If you look at all our values there, you don't even have a negative there. Okay, you do have a negative there. And then you have a negative there. Only 2 negatives. So it's almost impossible for you to get a negative amount. But in any case, let's do the calculation and show. Right, so x, that's our x times our y. This is our y there. So you might want to drag that down there. Total, there you go. It's 1,803. So basically, none of those values are correct. So we stick to 5 there. Very easy. Which of the following statements? So now we need beta coefficients, right? We basically need to calculate beta coefficients. So I'm just going to run the regression there quickly for us. So the first assignment always has this this thing where you have to run the regression. Right. So how that on Excel, you come to data, right? You come there to data. Right. I just clicked data there. Oh, did I click? Okay, I just clicked data. There you go. And then you come to your data analysis. Mine is already on regression there. So you basically scroll down there on your analysis tools until you get your regression. So if you are failing to get this, if you go to your data and you don't have this data analysis, you simply need to come to your file there, and then you come to your options, right? And then you come to your add. All right. And then see, normally this analysis tool pack is going to be under inactive application add in. So you just click it there and then you go on OK. It should add there. All right. Assuming that you have it, let's regression there. All right. Let's run our regression. So here we put in our y range. Yeah? So this is our y and this is our x. So which means with any given set of data, you need to be able to identify which one is your x and then which one is your y, right? And then we do that. Matter of fact, let me put it from here. Right. There you go. Let's put that from 1 there. We need labels, yes. We want residuals again on a new worksheet. Right. Then you just press OK. So this is the results that we get there. All our answers right here. So we have our intercept. This is what we are interested in. Our intercept 4.1 and our other intercept here, which is I wouldn't say, let me just say our beta coefficient, right? It's not an intercept in terms of it being the y-intercept. So these are our coefficients here. So this is beta nil, beta 0, and then this one is beta 1. So beta 0 is the intercept, right? The constant, this one is constant, and then this one is the x variable on that one. So we have minus 0.84 and then 4.61. Let's see what the question requires anyway. All right, so beta 1, they are saying it's 4.64. I think we already saw that the case, right? So this is 1. So this is 0. Your intercept is 0, and then your export is 1. So our beta 1 should be minus 0.084, and our beta nil should be 4.61. That's what we're looking for there. Okay, so this is the closest that we have, but the problem is now it's a positive and we're looking for a negative, right? We can recheck that again. Ours is negative. So these signs are very important. They mean a lot because they talk about right. These signs, basically, this sign here means a lot. It cannot be ignored. So it's minus 0.84. So the closest that we have is a 0.84. So we don't want anything close. We want it to be exact. So none of these ones are correct. So we stick it at that. All right, then which of the following statements is correct? So the observation of growth is obviously not in percentages, right? It's obviously percentages. I think at the beginning of this question, we were given, all right, it's actually given, sorry. Okay, annual percentage is actually given as a percentage, right? And then the exports of goods and services also again as a percentage of P. My bad. I thought it was going to be in billions. All right. So which means we're obviously not looking at this answer there. We're obviously not looking at this answer. These are our options. So we are looking at it in 2010. Let's go to 2010 and see what was up in 2010. Right. When is 2010? So 2010 is somewhere at the bottom there. It's how many up? Right. 10 is about 13 up, ne? So we can observe there on our plots. And there, so we say it should be 13 up. Let's have a look at that. We're on 11, 12, 13. So this is just about it. Right? Is it 2.4? All right. Let me check again. Sorry. I think it should be this one here. It should be this one. Right. Let's see. Right, that's basically okay. All right, so from this here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So it's 13, and then here it's only 12, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12. So this is our 13, the observation. So it's 2.44. So we're right the first time. So let's see 2.44 there. All right, there we go. It's a 2.44. Let's see if it's rounded to 2 decimal places, what that gives us. It gives us 2.45. Right? That's a 2.45. So which means our only correct option there is A. So we stick it at that. All right. E is the residual, right? E is the residual. So we're looking for the residuals in 1994. 1994, this one is easy. First year, right? Let's just confirm that starts off in 1994. There you go. So that's the first observation there. All right. So predicted growth, but we want the residual 0.23 or 0.228. Right, let's check that against our solution 0. This is, so we know that A is correct so far. So which means B is wrong, A is correct. So let's see what was on 2018, the observation, the 2018 observation, and then we can see if it matches that solution there, the one that's given. So we move down to 2018. Let's see, where is 2018? 2018 is somewhere here, right? So this is observation number what? Count, it's 5. So let's go from the bottom. We want 5 from, it's just about here, right here, minus 0.774. Right. So this one is positive, right? So the only problem that we have with this is that it's positive. So that's the only thing that makes it wrong. So we stick to the only option there that's correct. All right, which of the following statements is or are correct, given that the estimated beta coefficient is minus 0.08416, then this means that, so this is in the context of what we are doing, right? If the exports are increased by 1%, right? If the exports are increased by 1%, then the growth is going to decrease by 0.8%. So these are in percentages, by the way. I think we saw that. But which one is the explanatory variable? We always need to remind ourselves that, right? Which one is the explanatory variable, and then which one is the explained, the dependent variable? So we are trying to predict our growth or to explain growth using exports. So which means exports are the ones that change, then cause a change in growth there. So which makes A correct, because that matches there with that 0.08, it's a percentage. And then again, we can see that when there's an increase there, there's a capturing that negative sign there. So a negative sign basically means a negative relationship between those two. When one increases, the other needs to decrease, right? So if A is correct, then B is wrong, because B talks of a decrease and a decrease. So that is wrong, right? And then if growth increases by, this is wrong, because they are treating growth as an explanatory variable there, whereas growth is supposed to be a dependent variable. I hope people will be able to see. If you are able to, please write down these answers. Just write down these answers as we are discussing them, so that in case people can't make whether it's 1 or 2 from the solution, they can refer back to your answers, right? Which one of the following statements is true? So now we are going back to that. So this module is a perfect fit. So if it's a perfect fit, our R squared has to be 1, right? Then they say our R squared 0.015. We need to check that. Then if an additional x variable is included in the regression equation, that then R squared is likely to increase. It's actually likely to, sorry, it's likely to decrease. They say it's likely to decrease, but instead the truth is it's likely to increase, right? you will see that on the video, how adding extra x variables can actually manipulate this into an increase. So C is wrong. All these options here with C, we can rule them out. And A, we can also rule it out. So we only have this option here, right? Option number 5. But let's just recheck R squared. Let me show you where we check our R squared on the solution there. All right, so what we did here is going to give us the R squared. 0.0, looks like it's 0.015. So we need to make an adjustment there. Yeah, 0.015. So only B is correct here. But none of the options give only B, so we still remain with that option there. So this in any case reflects a very weak goodness fit, right? But we will deal with that again. This usually comes out in examination questions, right? R squared and adjusted R squared. It's an area we need to really cover a lot. All right, question 11 to 13 requires you to estimate the regression equation. Now we've got this one added, we've got equation 2. So let's make some additions there on our regression. So we want to rerun this equation, regression now. Right, you want to rerun this regression now, but we are going to include 2 exploratory variables now. We are going to include exports and the FDI, foreign direct investment, I believe. Right. So what do? We are still on data. We come back to data analysis. It's a regression. Yes, we choose regression. The Y range, so the Y range is still the same. Don't need to make any changes on that. But X range, we want 2 X's now. So we say start there. So I press Control Shift and then the down arrow, selecting everything. So we are the label and add on a new and one also. So we click OK. So for us. Right. So the question. So all your solutions are given then. So on the question, right, the question, our first beta coefficient, which is the constant, is given as 6.105, and then beta 1 minus 0.161, and then beta 2 0.327. So let's see if any of those match what's given there. Right. So the first one is 0.45. Right. Let's see from the one that's given there. I'm just gonna quickly check it. 105. Okay, we have it there. Right. And then the next one is minus 0.161. Okay, we have that on the solution, and then 0.327. 0.327. So that's basically there. So looks like every one of these there are correct. Right. All of these here are correct. Right. Number 12. Which of the following regarding estimates of equation 2 correct? So now we are looking for the standard errors. Right. So we are given, this is just for this. So which means not all of the correct. So we are just checking these ones, see what the correct one is. So this, we're looking at standard error. So this is standard error right there. This is our standard error. And then for this is beta not, remember, and then this is beta 1, beta 2. So we want for beta 1 0.144. So we are looking for the option now with 0.144, which is the best option. Right. I'm just waiting for the screen to change. All right. The 0.144, which is A there. Right. We click that. Then which of the following statements regarding estimates there is correct? Right, so let's assess this. So RSS, which is the residual sum of squares and then the estimated sum of squares. So this is just given as it is, and then adding FTI model has improved the fit significantly. So we are gonna check that now. Let's start with the fit. Let's assess the goodness fit here. Right. So the goodness fit started off on, let's take the R squared there, which means goodness fit, but the more appropriate measurement is this one, the adjusted R squared, which is that negative 0.2164. Then it moved to 0.001. So I wouldn't exactly call that a significant change. I wouldn't really call that a significant change. So the word significant is very relative. I don't think they should have used that word there. What significant to you could be insignificant to the next person. 11.46 and then 146.05. Let's see on those two. Right. 11.46 and then 146.05. So B and C are correct. So we mark that there. We are almost done. We're done with the regression questions now. All right, now, this is a calculation. This requires a calculation. So we'll do the calculation. Let's start on question 50. Research to investigate the factors that determine the number of children per family. The variable number of children is this is just, right? This is obviously, you can count it, it's a discrete variable. You can count it, it's a discrete variable. So we'll go for option 1 there. So let's calculation on question 14 and then we can call it a night. Just put up this information on the Excel sheet there so we can do the calculation there. Right. I'm just gonna put it up there. So I'm just punching in the numbers 3, 4, 5. And then we have 0.012, 0.32, 0.372, 0.194, 0.077, 0.025. So I was just putting in these numbers. Let me see if I got it. So the first one is 0.012, the next one is 0.32, 0.194, 0.077, 0.25, right? Let's take us there. Right. This is what I was typing there. Let's put this on here. Basically, what I was up to there. Right. So that's our X and our probability of X, and then our P there. Right. So back to the question. Let's see what the question wants. All right. So the expected. So we need to calculate now because they are saying which of the following statements are correct. So we need to calculate the expected value, the variance, and the standard deviation. So we calculate it typically in that order anyway. All right. So let's say expected X. Put it there, and then the variance. We can put it there, and then let's just say the standard deviation. We'll put that one there. So this is the question. If you were about to sleep, do not sleep. We are almost done. Should be done in the next 5 minutes, less than 5 minutes. Right. All right. So EX is the summation of and that summation of X quickly. Right. John Jesus is, and then we want to put that up there to give us 1 S. Right. That's the expected value. Right. How about the variance? The variance should be given as a right. Right. The variance should be given as, sorry about that. The call was disturbing me. The variance is supposed to be right. It's x minus ex that it's in square and right. So let's just normally x, right? Let's x. Let me put this kind of bracket. Okay, to the power of 2, we are squaring that thing. Right? And the reason why we square that so that we don't get any negative values there. Then the answer that we get, we are not. All right. So I say right our minus in this behind x and all right, just writing that different. So let's apply whatever we did at formula. Apply that okay, so speaking that up right. So let me base on so let's log that. All right. Good. So now we have the same value there and the same value there. Right. So if you have issues with that, then what's the even look at? Let's see. So if you have issues with them, you can just manually. You can just do it manually, but this is more accurate. So let's put up the summation. Let's finish this up. Right, we are adding that there. That's our variance. Standard deviation is the square root of the variance. So square root is that to the power of half. Right, 1.04. So let's see now if our answers match what's given there. All right, so let me see, let me open that on the side there. All right, so I can view the answers here on the side. 2.079, the first one is correct. The second one, 1.089 is correct. The third one, 1.043 is correct. All right, let me just show you those answers there. The answers. So we have those ones there. So do we have any questions here before we can put this one? So we are looking for what? So the correct one. So option 4 on this one. Let me say this. Do we have any questions? Last 5 minutes. Any questions? Any questions? Any questions? No questions. All right, perfect. So what we are gonna do now, next on our next session, I think I'm gonna send the video sometime, maybe tomorrow. I'm gonna have load shedding now, so I'm not gonna be able to check the video. But probably tomorrow, I'm just gonna send the video, which is gonna cover chapter 1 and number 2, right? And then on our next session, we will start off. This is supposed to be that one. So we start off with 20 minutes tackling questions, and then the last, hopefully, I don't want to go to 1.5 hours, hopefully up to an hour. We then tackle anything that is outstanding on question on 1 and 2 while we proceed to the other topics. All right, thank you so much for joining us. Enjoy the rest of your time.